Hi, in this video we will do a couple more examples of solving rational equations. So again, when we want to solve rational equations, we want to get rid of our denominators, and the way that we do that is multiply through by our least common multiple. So in this problem, I'm looking for the least common multiple of 3 and 2. I know that to be 6. 6 is the smallest number that both 2 and 3 will go into. So I'm going to multiply every single term by 6. And I can't leave anything out. Even if it's a number without a denominator, it still has to be multiplied by the 6. Otherwise, I change the problem. Okay? So now I'm going to go through, and if you do it correctly, all your denominators should go to 1. 3 goes into 3 once, 3 goes into 6 twice. Now, with this 2 here, I need to make sure that it gets distributed to everything in the numerator. So my first term is going to become 2x plus 2. All right. The second term, 2 goes into 2 once, 2 goes into 6 3 times. And now I want to make sure this is actually a negative 3, because I have the negative sign here, gets distributed to everything in the numerator. So my second term becomes minus 3x plus 3. And on the right-hand side, don't forget, that also has to be multiplied by the least common multiple. So 6 times 1 leaves me 6. Now once I have it to this point, I can solve this just like any other equation. Combine like terms, 2x minus 3x combine to give me a negative x. 2 and 3 combine to give me 5. On the right-hand side, I have a 6. And now I'm going to subtract 5 each side. I get that minus x equals 1. And now to isolate x, or get rid of the negative, I can think about this as either multiplying or and I get that x equals negative 1. Now remember, whenever we're solving rational equations, we have to make sure that if we plug our solution back in, it does not give us something undefined. I don't really have to worry about it in this case because I have no variables in the denominator, so I'm fine. This is actually the solution. Now let's turn our attention to this problem. If we have just one term on each side, then we can solve it basically by doing something that we call cross multiplying. Okay? In other words, I'm going to multiply the numerator of one side by the denominator on the other side and set it equal to the numerator on the other side times the denominator on this side. In this case, it would be x minus 1, numerator, times x minus 5, denominator on the other side. And you'd set that equal to 4, numerator on the other side, times x minus 5, denominator on this side. On the left-hand side, I'll have to multiply this out by using FOIL. I get x squared minus 6x plus 5, and set that equal to 4x minus 20, because 4 times x is 4x, and 4 times negative 5 is negative 20. Don't forget to distribute. Now, I'm solving a quadratic, so I want to get all my terms on one side. In other words, I want to get this equal to 0. So I'm going to have x squared minus 10x, okay? Because in order to get this over, I'd subtract 4x each side. Negative 6x and negative 4x would yield a negative 10x. And then I'm going to have plus 25, because in order to get the negative 20 moved over, I would add 20 each side. And now that this is set equal to 0, I can solve it using factoring. I'm going to factor this into two terms. I'm looking for two numbers. When multiplied together, gives me 25. Added together gives me negative 10. So I get x minus 5 and x minus 5. Because negative 5 times negative 5 yields a positive 25. Negative 5 plus negative 5 yields a negative 10. And that means that I have one solution at x equals 5. However, if I go back to my original problem and plug in the 5, down here in the denominator, I would get 5 minus 5. That equals 0. Remember, whenever we have a 0 in the denominator, it is undefined. So this, in fact, is not a solution. We call this an extraneous solution, meaning that we came up with one, but it's an extra one. It has no meaning. All right? So in other words, in this case, because we only came up with the 1, we would have to conclude that there is no solution. Okay? So remember, when solving rational equations, your last step should always be to plug your answer back in and make sure that it does not yield something that is undefined.